The journey of the sun, our life-giving star. The sun, a dazzling celestial body that has enraptured humanity for thousands of years. Its presence provides warmth and sustenance, but how frequently do we ponder its origins or its ultimate fate? Though often assumed constant, the sun's saga is one of monumental evolution and cosmic significance. In this lecture, we'll take an enlightening voyage through the sun's life cycle, from its fiery inception amid cosmic turmoil to its serene twilight as a white dwarf. We'll explore the science behind its current stability, the transformative phases it will experience, and the profound impact it has on the universe around us. This isn't merely a tale of the sun, it's about our place in the cosmos. By delving into the life cycle of our star, we aim to spark curiosity about the universe and kindle a richer appreciation for the formidable forces that render life feasible. Approximately 4.5 billion years ago, the solar nebula, a colossal cloud composed of dust and gas, began to collapse under gravitational forces, likely catalyzed by shockwaves from a nearby supernova. As this nebula condensed, rotational speed increased, forming a flattened disk. The material concentrated at its center faced intense pressures and temperatures, triggering the dawn of our sun. At the heart of this process, nuclear fusion ignited. Hydrogen atoms collided and fused into helium, releasing vast energy amounts. This moment signified the birth of our sun, blazing brilliantly in one of the Milky Way's spiral arms, the Orion Arm. The sun earned its classification as a G-type main sequence star, or G2V, serving as just one of billions in our galaxy. Yet, it holds a unique position, enabling life on Earth. The sun's formation didn't merely mark the creation of a star, but heralded the genesis of an entire solar system, with planets forming from leftover debris in the surrounding disk. In the ensuing 4.5 billion years, the sun has exemplified perseverance within the main sequence phase, the most stable period of stellar life. Here, it finds equilibrium between two mighty powers, the inward force of gravity and the counteracting outward pressure created by nuclear fusion at its core. This balance allows the sun to shine steadily, sustaining conditions necessary for life on Earth. Deep within the sun's core, temperatures soar to a staggering 27 million degrees Fahrenheit. It's here that hydrogen undergoes continuous fusion into helium, a reaction turning immense amounts of mass into radiant energy. This energy ushers forth through layers of turbulent plasma, eventually escaping as familiar light and heat. Some of this reach our Earth, nurturing photosynthesis, influencing weather cycles, and supporting ecosystems. The sun's surface brims with dynamic phenomena, from fervent solar flares erupting into space to cooler, darker sunspots, tangible signs of its complex magnetic field. Yet, despite this ceaseless activity, constancy defines the sun, securing its role as the solar system's heart and the life-enabling star as we know it. However, like all stars, the sun's fuel reserves are finite. While its main sequence phase endures expansively, it isn't everlasting. This enduring stability only precludes an era of forthcoming dramatic transformations. In approximately 5 billion years, the sun will commence depleting the hydrogen fuel once abundant in its core. As fusion diminishes, the delicate balance between gravitational forces and internal pressure will falter, sparking a succession of striking changes. The sun's core will constrict under its own weight, growing hotter and denser, while its outer shell balloons outward. This metamorphosis will inaugurate the sun's next phase, a red giant. During the red giant stage, the sun's expansiveness will magnify to encompass possible celestial neighbors, including Mercury, Venus, and perhaps Earth. Its luminance will shift into a redder hue, outshining its former brightness, though the surface will significantly cool. This phase's expansion arises from helium fusion, a sequence where helium atoms fuse into heavier elements such as carbon, releasing substantial energy. With these transformations, the sun's outermost layers will destabilize, eventually drifting into space, creating a beautiful planetary nebula, a brilliant shell of gas announcing the sun's departure from its previous grandeur. What will remain? Just its dense, exposed core. While the transformation into a red giant is visually spectacular, it signifies the sun's transition from a fully active star. This altering phase reshapes not only the Sun, but the entire solar system, altering planetary orbits and remaining celestial bodies' conditions forever. After shedding its external layers, only the exposed core will continue, transforming into a white dwarf, symbolizing the final phase of its life cycle. A white dwarf defines a small, dense remnant, no larger than Earth, yet retaining most of the Sun's original mass. No longer will it produce energy via fusion, but its faint glimmer will linger as it cools gradually over eons. Among the universe's most intriguing objects, the Sun's evolution into a white dwarf encapsulates a spectacular journey. Compact beyond comprehension, its density means a mere teaspoon of its material could weigh tons. Despite diminished luminescence, the Sun's influence endures, its gravity continuing to exert hold over surviving planets and solar remnants. With time, the white dwarf will fade into obscurity, likely becoming a black dwarf, a cold, dark echo of its vibrant past. However, the universe is not yet old enough to hold any actual black dwarfs, so the Sun's white dwarf phase will span billions of years before reaching this stage. This quiet, subtle end contrasts boldly with the Sun's lively history, yet it represents an apt, natural conclusion to its stellar voyage. Even in this ultimate form, the Sun remains a testament to the universe's eternal cycles of creation and transformation. Reflecting on the Sun's sweeping journey, from fiery emergence to retiring stillness, invites reflection on how deeply interwoven its life cycle is with our own existence. Every atom in our bodies shares an origin with those born from ancient stars such as the Sun, making us literal children of the cosmos. The Sun's life cycle further highlights life's remarkable fragility. Although changes occur on a timescale far outstripping human lifetimes, they serve as powerful reminders that what we perceive as constant is part of an evolving and vast universe. The Sun's transformation into a red giant will indelibly alter our solar system, ending the environment that fostered Earth's flourishing conditions. Nevertheless, the Sun's narrative transcends mere endings. It invigorates us to look beyond the familiar, to seek and find answers about our role within the cosmos. By studying its life cycle, humanity gains not only invaluable knowledge, but also a broader perspective, a deep-seated awe for the exquisite balance sustaining life. This cosmic journey, from the Sun's vibrant present to its tranquil, distant future, binds us to the universe in profound dimensions. It challenges us to cherish curiosity, cultivate scientific discovery, and contemplate our relationship with the forces shaping our existence. The Sun's life cycle is an astonishing odyssey, a vibrant chronicle of birth, steadfastness, transformation, and eventual repose. From its fiery beginnings within a stellar nursery to its serene final phase as a white dwarf, the Sun's tale encapsulates universal cycles of creation and renewal. The Sun's existence is more than mere cosmic mechanics. It is a profound reminder of our intrinsic link to the stars. The very energy fueling the Sun has sculpted life on Earth and continues to nourish it. As the Sun itself undergoes evolution, it dares us to ponder our place within this grand cosmic narrative. As we conclude, let's collectively appreciate the Sun's profound impact, not solely as the light warming our planet, but as a beacon of the universe's vast wonder. Should this journey through the Sun's life cycle have sparked your inquisitiveness, share it widely, delve deeper into cosmic phenomena, and persist in questioning the universe around us. The cosmos holds endless wisdom awaiting discovery. If you enjoyed this content, please comment, like, and share with friends to further spread the wonder and knowledge of our life-giving star.